Sorry, got all a little off there. All right, so now we're going to talk about 5-5. Now 5-5 is function operations between two functions. So it's the basics. Adding, subtracting, multiplying, and dividing are the main ones. And really you do kind of exactly what it tells you to do. Like if it says addition, if it says here, this is what it would look in function notation, that f plus g of x. Well, that means you're going to take f of x plus g of x. So for example, if I gave you these two functions, 5x, f of x is 5x, and g of x is x plus 2. If you ask for f plus g of x, we're going to add those together. 5x plus x plus 2. We combine like terms, 6x plus 2. If we're subtracting, so f minus g of x, again, same idea. Take the first function minus the second function. So if we were doing f minus g of x with these same two functions, f of x is 5x minus x plus 2. It's really important that this second one, when you're subtracting, you think about it being in parentheses, because it's really easy to forget that you're subtracting both of those. So this is 5x minus x is 4x, and then you also have minus a positive 2. That's where the minus 2 comes from. It's really easy to forget to subtract the second one. So if we were doing this problem down here, we're adding and subtracting. So here it says find f plus g of x. So f plus g of x is telling us to add those together. So that's 3 radical x for f of x and a negative 10 radical x for g of x. We add those together. We get a negative 7 radical x. Now notice it also here is asked you to state the domain. Well, if you remember for domain, there's two things we look at. One of them is an even root, like a square root. So we know that for the domain, the number underneath the radical here, that's just x, has to be greater than or equal to 0, because we can't do the square root of a negative number. So here the domain is x is greater than or equal to 0. Then it asks for f minus g. So for f minus g, we're going to subtract. So we're going to take a 3 radical x minus a negative 10 radical x. Well, that's 13 radical x. The domain would be the same because we still just have an x under the radical. Now it asks us to find those for 4. So if we were finding f plus g of 4, well, we've already done it, so we can plug it in here, but you can also do it from the original. You can plug 4 into f. Well, if we plugged 4 into f, that'd be 3 square root of 4. Then we can plug 4 into g. So that would be negative 10 radical 4. So that's 2, so 3 times 2 is 6. Minus 10 times 2 is minus 20. We get a negative 14. Or if we were doing f minus g of 4. And you could, since we've already done these like f minus g, we could plug it right in there, which is fine. So like here, this last one, we could have just plugged it in the end. We could have said, okay, that's a negative 7 times the square root of 4. Negative 7 times 2 is a negative 14. But I was just showing you we can also do it without adding them together first if the problem asked you to do that. So f minus g of 4, if we plug it into what we found here, that'd be 13 times the square root of 4. That's 13 times 2, 26. We could have done it from the original functions. That would be f of 4 is 3 radical 4 minus g of 4, which is negative 10 radical 4. So 3 times 2, that's 6. 10 times 2 is 20, also 26, so it works either way. Same with this one here. I'm going to do this in reverse order. So here I'm going to find f plus g of negative 2. So I'm going to find f of negative 2 first. So I'm going to put negative 2 into f. So that's 3 times a negative 2 cubed minus 2 times a negative 2 squared plus 5, which is, let's see, that's going to be a negative 8. So that's negative 24. That's 4 times a negative 2 is minus 8 plus 5. This is a bad one to do this long way. So anyway, if I finish, that's f of x. Now g of negative 2, if I plug g of negative 2, that's a negative 2 cubed minus 3 times negative 2 squared plus 4 times negative 2 minus 2. See, negative 2 cubed is a negative 8. That would be 4 times a negative 3 is a negative 12 minus 8 minus 2. Now this one would have been better off adding them together first, because now we would combine all those. Let's go back and add them together first. Let's find f plus g of x. So we're going to add these two together, so we're just going to combine like terms. So we have a 3x cubed and an x cubed is 4x cubed. We have a negative 2x squared and negative 3x squared is a negative 5x squared. We have a 4x and there's not an x in the f. And we have 5 plus a negative 2 is plus 3. So that's f plus g of x. Here it asks you to find the domain. Well, unless you see a square root or the denominator of a fraction, the domain is all real numbers. Right? You could put a fancy r, or you could put negative infinity to infinity for domain, either one of those. Or x is less than infinity and greater than negative infinity. That all means the same thing. Well, now if we want to find f plus g of negative 2, it's probably a little simpler. So we have 4 times a negative 2 cubed minus 5 times a negative 2 squared plus 4 times a negative 2 plus 3. So we just put negative 2 in for all of the x's. So this would be a negative 8 times 4 is a negative 32. This would be 4 times a negative 5 is negative 20. 4 times a negative 2 is minus 8 plus 8. If we add those together, well, that was a 3. I thought that I read that as an 8. My eyes are failing. That's a 3. Sorry about that. I think that adds up to a negative 57. Now if we did f minus g, so just remember we're subtracting all of them. So 3x cubed minus x cubed is 2x cubed. Negative 2x squared minus a negative 3x squared is plus 3x squared, so plus x squared. Here I don't have an x, so this would be like no x minus 4x is a negative 4x. And then 5 minus a negative 2 is 5 plus 2, or 7. You have to be really careful to remember to subtract all of those. Well, now if I want to find f minus g of negative 2, we substitute in a negative 2. So 2 times a negative 2 cubed plus a negative 2 squared minus 4 times a negative 2 plus 7. Sorry, I had all that off the screen. Sorry about that. So f minus g, when we subtracted, we got 2x cubed. We got a positive x squared. We had a negative 4x, and we had 7. Then we substituted negative 2 in for each of the x's. And now we simplify. That's going to be negative 8 times 2 is a negative 16. That's 4. That's a positive 8 and plus 7. Looks like that adds up to 3. If they ask for the domain of f minus g, the domain would be all real numbers. Okay, that's adding and subtracting. Now, multiplying and dividing. Again, it's just you do exactly what it says. To multiply, like see this says f times g, you take f of x times g of x. So like here, there's our same 2. F of x is 5x, g of x is x plus 2. For f times g, we take 5x times x plus 2, so we just distribute, get 5x squared plus 10x. When you divide, you do the same thing. If I'm dividing f over g, that tells you take f of x divided by g of x. So here that would be 5x over x plus 2. Now I will say when you divide, because you're probably going to end up with a denominator, you want to include the domain. Remember we said one of the things in the domain was an even root. Well, the other thing is a denominator. Here we know the denominator of a fraction can't be 0, so we say that. So for our domain, we say x plus 2 cannot be 0. So we solve for x, we subtract 2 from each side, so x cannot be negative 2. So down here it says we want to find f times g of x and f divided by g of x and state the domain. Then we want to find the value. Now these I would definitely do this part first and then substitute in the numbers. So here if I'm finding f times g of x, that means we're multiplying. We're taking x squared times radical x. So that just gives you x squared radical x. Now the domain, again, we have a square root, so the number underneath the square root, x, has to be greater than or equal to 0. That's our domain. Now I'm going to go ahead and find 9 here. So if I want f times g of 9, we're going to put 9 in for x. So 9 squared times the square root of 9. So 9 squared is 81 times the square root of 9, which is 3, which is 243. Now let's do the divide one. So f divided by g. F divided by g of x. Well, so we're going to take f of x, which is x squared, divided by g of x, which is radical x. Now here we have a denominator and we have a square root. So we have both of those things. So for our domain, for a square root, we would normally say x is greater than or equal to 0. But since it's also in the denominator of a fraction, it can't equal 0 either. So we're just going to do greater than 0. So that's our domain. Now to find f over g of x, of 9, we're going to plug 9 in, so that'll be 9 squared over the square root of 9, which would be 81 divided by 3, which is 27. Okay. For this one, same idea. We have a different f and g. Now we're for f times g. So f times g of x, we're going to multiply. So we're taking 6x times x to the 3/4. Now here, to simplify that, we know this exponent is really 1. Remember when we multiply, we add exponents. So this exponent is 1. That's like 4/4. I'm going to leave the 6 there, but so when we add, we have 4/4 plus 3/4. So that's x to the 7/4. Now for the domain, here, whenever you have an even root, remember this below bottom number means this is the 4th root. You can't do an even root of a negative number. So for our domain, x cannot be negative. So we say x has to be greater than or equal to 0. Now if I want to find f of g of 16, we're going to plug 16 here. So it's 16 times 16 to the 3/4. Now for this, leave the 6. Remember, this is the 4th root. So this 4 means the 4th root of 16, which is 2. And then 2 to the 3rd is 8. So this is 6 times 8, which is 48. Again, when you have an exponent that's a fraction, the denominator is the root. So this is the 4th root of 16, which is 2. The numerator is the exponent. So now we have 2 to the 3rd power is 8. So that's where this 8 came from. If we do f over g of x, well, now we have 6x on top, and we have x to the 3/4 on the bottom. You can actually simplify this. Remember, when we divide, we subtract exponents. So here, this x is to the 4/4 because that's a 1. Well, when you divide, you subtract. So 4/4 minus 3/4 is 1/4. So this is actually 6x to the 1/4. Now for our domain, again, this is an even root, so x can't be negative. So x is greater than or equal to 0. Again, because you can't find a square root or any even root of a negative number. Now when we want f of g of 16, so that's 16 times 16 to the 1/4. Again, when the exponent is a fraction, the bottom number, the denominator, is the root. So this is the 4th root of 16, which is 2. And 2 to the first, because the top number is the power, is just 2. So this is 6 times 2, which is 12. Okay? So that's add, subtract, multiply, and divide. I want to cover one more. This is not in your thing, but I want to talk about it anyway because we'll actually use this later. The next stage is called composite functions. Composite functions are where you plug one function into another function. And it looks like this. This is read f of g of x. This is another way to write with this little, looks like a little circle in between. That's the same thing, f of g of x. What that's telling you to do is substitute the inside function. So that's g of x. Same thing here. Here it's the one inside the parentheses. Here it's the second one. That's the inside function. We're going to plug that into the outside function. So you substitute what's inside the innermost parentheses in for x in the outside function. So if we use those same ones we had right here, where f of x is 5x and g of x is x plus 2. If I ask for f of g of x, that means I'm taking g of x, which is x plus 2, and I'm going to put it in there in the other function. That's 5 times x plus 2. Do you see that I put g, x plus 2 in there for that x? That's all we did. You simplify 5x plus 10. If it was written the other way around, g of f of x, that again, we take the second one, f, we substitute it into the first one. So here we're taking 5x, and we're going to put it right there in place of that x. So that'll be 5x plus 2. If I ask for this, this is read f of g of 1. You can work your way from the end back to the beginning. So first we plug 1 into g. Well, if you plug 1 into g, 1 plus 2 is 3. Now we plug that into f. So we put a 3 in here. 5 times 3 is 15. So again, there's no multiplying involved. You'd be tempted to do that. But you plug the number into the last function. So 1 into g. 1 plus 2 gave us 3. Then take that answer and plug it into the leading function, to the f, the outside function. So that was 5 times 3, 15. Same idea on this one, g of f of 2. First, plug 2 into f. If we plug 2 into f, we get 5 times 2, that's 10. Then take that 10 and plug that into g. Well, that'd be 10 plus 2 is 12. Again, there's not anything in here, but we do use that in the next section, but those are called composite functions. And that's it for 5.5.